We are going to solve one-step equations today. In order to do that, you need to remember our inverse operations. We are going to be undoing the problem in order to solve the equation. So if my operations are addition, subtraction, multiplication, and division, what is the inverse operation of addition? That would be subtraction. What is the inverse operation of subtraction? That would be addition. What's the inverse operation for multiplication? That would be division. And what is the inverse operation of division? That would be multiplication. So when we're working through solving equations, this is our one-step equations. But as we move on to two-step and multi-step, you're still going to be using the inverse operations, working opposite or backwards in order to solve these equations. So we're going to jump right in. I'm going to do the problem down one side, and on the other side I'm going to write the steps that we took. So our first equation is x plus 10 is equal to 57. Now the steps to solve. Step 1 is to isolate the variable. And to isolate means to get it alone. Isolate all by itself. Now in order to do that, here is my variable. In order to isolate that variable and get it all by itself, I need to move that 10. So what I like to do is just put a little dotted line down my equal sign. This is to keep balance. This is like a seesaw that goes up and down that you see at a playground. I don't want to see one side up and the other side down. It has to be equal going across, which means that whatever I do to the left side of that dotted line, I need to do the same thing to the other side of the dotted line. So that dotted line is going to help me keep balance when I go to solve my equation. So step 2 is to move the value, and in this case the value is 10, by using the inverse operation. So if 10 is positive, it's plus 10, so it's positive 10. What would be the inverse of that? And that would be to add a negative 10. So I am going to add a negative 10 to both sides of this equation. These are going to cancel out because a positive 10 is added to a negative 10, and that are opposites. They give you 0. Bring down your x equals 57 plus negative 10 is going to give me 47. So x is equal to 47. So let's check that. X plus 10 equals 57. Take your answer that you got, which is x is equal to, and I want you to put in for x that 47. So 47 plus 10 equals 57. 57 equals 57. Check. So that answer of 47 would be correct. All right, let's do number 2. I have 4 examples, I believe. One of each type. All right, so example 2. We have x minus 7 equals 15. So step 1 is the same. Isolate the variable. So we want to isolate this variable. But once again, as I've said before, whenever you see subtraction, you need to use your keep, change, change. So this would be x plus negative 7. Change subtraction to addition. Change positive 7 to negative 7. I'm going to draw my dotted line. Step 2, move negative 7 by adding its opposite. So if this is a negative 7, I'm adding a positive 7. I want these to cancel each other out. So I'm adding a positive 7 to 15 as well. So this would give me x is equal to 15 plus 7 is 22. Last step would be to check that. So let's check. We have x, I'm just going to copy it like we have it up here, plus negative 7 equals 15. I'm going to substitute in for x my 22 that I got, plus negative 7 equals 15. 22 plus negative 7 is equal to 15. Since it is the same on both sides, it keeps balance, and that would be the correct answer. All right, example 3. 8y equals 72. So again, we are going to isolate the variable. And when I do that, I like to put a box around my variable. I want that all by itself. So I'm looking at this problem now. I don't see any plus signs. I don't see any minus signs. When you have, and we've talked about this, when you have your coefficient and your variable right next to each other, we know that that's multiplication. So the inverse of multiplication is division. So here I am going to use the inverse operation, which is to divide by 8. So I have to divide by 8, and I want it written just like this, making it into a fraction. If I divide by 8, 8 divided by 8 is 1. It disappears, and I'm left with y equals 72 divided by 8 is 9. So we want to check our answer. So if we check, we have 8y equals 72. 8 times 9 equals 72. 72 equals 72. Check. All right, last example. And I've given you one of each type that you're going to see in your assignment. K over 4 equals 13. All right, once again, we have to isolate the variable. Now my variable is part of a fraction. Whenever you see a fraction, you immediately think division, okay? This is division. And the opposite of division is multiplication. So we are going to multiply both sides by that denominator. So I'm going to copy it again. K over 4 equals 13. I want to isolate that. So in order to eliminate the denominator, I need to multiply by that denominator. When I multiply both sides by that denominator, I am eliminating it from here. So that would give me K equals 52. So now check. So I will take K over 4 equals 13. 52 over 4 equals 13. 52 divided by 4 is 13. So this is 13 equals 13. Check. So there's one important rule besides knowing that we have to keep and do the opposite operations. There's one thing that's really, really important, and that is to keep balance. So one thing I want you to remember besides always using the inverse operations, so remember we use inverse operations to solve equations. And the second thing I want you to remember is to keep balance. Whatever you do to one side of the equation, you must do on the other side of the equal sign. Okay, so whatever you're doing, you keep balance. You must do the same thing, same operation to both sides of the equal sign.